In this video, we're going to be discussing the idea of a function, okay, and what the heck they are. You notice I write that right there, but a function, okay, we're going to start by talking about a function with respect to what we call a relation, okay, and so what I want to start by saying is this: a relation, if you think about this in, the English language, or you can translate to any other language you like, but a relation, this is a concept that we already are kind of familiar with, what relations are, okay? How one thing basically, to be redundant, relates to another. So a relation might be, say, for example, there's a relationship between how long, say, a high school student works and how much money they make. But there would be necessarily a relationship between time and money, or necessarily, how about we look at, say, the day of the month and the given temperature on that day, okay? But there's a relationship between the day of the month, or maybe the month of the year, and the average temperature. Those things tend to change with specific relationships to one another. So often in math, we define numerical relationships, and we typically do so with rules, we say, or equations, but it's important to understand this idea of a relation, okay, before we can understand this idea of a function, all right? But let's go ahead and start by talking about what a relationship, or a relation, excuse me, is in the first place. We tend to define a relation as a connection, say, between a set of one things with respect to a set of other things, okay? So I'm going to draw on kind of these two sets here, and that looks kind of odd right now, but we'll call this set A right here, and what I'm going to do is I'm going to refer to these as input values, okay? And then set B over here, we'll refer to these as output values. But I find that maybe we can start by using, say, some numbers to set up maybe a relation, and then talk about how a function and a relation are themselves related, okay? So let's talk about this. We say input over here. Input, maybe we go with the numbers 0, 1, 2, and 3, and then over here we'll go, for the sake of simplicity, 4, 5, 6, 7. Sorry if that's very boring for you. But let's go ahead and talk about this. Okay, so we tend to define a relation as a series of, or a relation between two different sets, and we tend to think of this as a series of input values that are mapping onto a series of output values. So it may be the case that in this specific relation, how set A relates to set B is that when we say input the value of 0, that we say maps on to a value of 4. And and algebraically we tend to think of input output as kind of being this, like maybe I put in this x and it pops out this y, for example. But this is one way to look at it. Or maybe the relation between these two sets says that 1 maps onto 6, or maybe 2 maps onto 5, or 3 maps onto 7. Okay, and again, we could explicitly write these out as these ordered pairs, 2, 5, and 3, 7. But what this does is it defines a specific relation between these two sets of things, this input and this output, okay? So the first thing I want you to notice about this relation is the fact that every single one of these input values over here, 0, 1, 2, and 3 respectively, notice how many output values each one respectively mapped onto. Each one of these inputs over here, when they mapped onto one and only one output value, okay? So what I want to point out about this relation instantly is the fact that this relation is not just a relation from these input values, this set of A, and set of, mapping onto set B here, but this is a special kind of relation, okay? This relation is also considered a function. So here's what we should probably do at this point. I'm going to draw like a mini Venn diagram here, but let's assume this box here. It represents all of the relations ever made in the universe, or the multiverse, depending upon whether you are into string theory or not, and whatever. I'm getting off track here, but this represents all the relations in the world. What I can tell you is this: within this set of relations lies a subset, okay? And this subset, we're going to call this the set of functions. I'm going to call this F for the sake of convenience. But what I want everybody to know is this: a function is a relation. It's just that a function is a very special relation. And we say that a function is a very special relation because not only does it relate a set of things to another set of things, but for every input in the function, which is a relation, that function is a relation, but for every input in a function, every value or every instance in the input set maps onto one and only one output value. Okay? So we lovingly refer to functions as things that happen to be one-to-one. That is, every one thing maps onto one and only one output. So you might be saying, okay, so what would be an example of something that is not a function? Okay, so what we'll do here is we'll switch over to yellow and we'll go back and we'll look at this first relation that we drew here, because a function is a relation, it's just a special one. What if in this first example I said, hey, 1 maps onto 6, but guess what? 1 is 1 likes to hang out with everybody in the output here, and 1 not only maps onto 6, but 1 mapped onto 5 as well. So over here I can even drop in this related set of points here, but when we stuck 1 into this relation, somehow it mapped onto 5, but you're going to notice here that the 1 mapped onto a 6, but it also mapped onto a 5. And so the first thing I want to point out is this is still a relation, okay, but this is not considered a function. And the reason why it is not considered a function is because we had one of our input values map onto more than one output value, okay? So it is fair to say that this is a relation, but not one of those special relations in which every one input maps onto one and only one output, okay? So today we're going to be concerning ourselves with this idea of function. We're going to be concerning ourselves with specifically relations that are one-to-one. Every one input goes to one output. And you know, if this is really just like making you go cross-eyed right now, let's put it this way, where every x value is allowed to only map onto one y value. And not only are we going to discuss this, but we're going to talk about the different ways of representing functions or non-functions, just relations, and how we can tell, how do I know if something is a function or not? Is it just a relation, or is it a relation and also a super special relation that we call a function? Okay, so let's go ahead and start talking about how we represent relations in the first place. And I'm going to come down here, and I can tell you this, you've noticed I've written here like example A, example B, we got C, D, and E. But not just the different ways of representing a relation, but also how can I tell if it's a function or not? I want to be able to tell if it's a function or not because we really concern ourselves a lot with functions. Okay, so let's start by looking at this first example, example A. You're going to notice that I've written the very, very popular Algebra 1 T-chart here, okay? But you could think of this T-chart as representing a relation that we are not at this moment sure if it also represents a function, okay? But recall that we define a function, and maybe I need to type this in here. And you know, I got a text tool here, and I guess I could switch over to a white color. Let's start by defining a function so that you, if you are taking notes, can get this down into your notes. But we define a function, okay? So a function is any relation that maps every input value to one and only one output value, okay? So this is what we use as our operational definition for what a function is, okay? So let's go back and look at this table over here, this T-chart that we were previously talking about. But, you know, you could think of this as a series of ordered pairs. That is, you know, every input X is being exported to some output Y. So we've got two, okay, trying to figure this out here. Maybe, all right, there we go. We have 2 mapping onto 11, 2 also mapping onto 10, 3 mapping onto 8, 4 mapping onto 5, and 5 mapping onto 1. This is some relation here, but the question is this also a function? So first things first, we are able to represent a relation using a table. Get used to this notation, but we can do this, okay? This is something we're already familiar with. But you might be thinking to yourself, okay, so is this one-to-one? And already I'm kind of making this stick out like a sore thumb, but you'll notice that 2 mapped onto 11. So we had an input map onto an output here, 2 to 11, but we also had the same input map onto another output, okay? So all of a sudden you're seeing that we have one input going to 2 separate outputs. And that actually, if we look at our operational definition of a function over here, violates the stipulation for also being a function. So we would say that this first relation right here, although a relation is not a function, it's not a function, okay? So this one is not a function. You know, and going hand in hand with this tableau or this table relationship, you can look down here as this. We represent a function as a series of ordered pairs. And just, no, we could put this in a table, okay, very, very simply. But check this out. If we consider all of our x values as input values and y values as output, now we're seeing that in this particular relation here, we say 0 maps onto 1, 2 maps onto pi, and 8 maps onto e. But the thing in particular to note here is this. Every single input value and every instance of an input, it mapped onto one and only one output. So this is not just a relation. We would actually also consider this a function. So you notice I didn't give this example here like the letter B, but only because both of these representations are kind of similar in the way we represent them, but through a series of ordered pairs or a table. Okay. So now let's consider example B here. Example B, you're going to notice I've already graphed a series of discrete points. That means there are gaps between them. Discrete's a fancy word for not continuous, but anyways. So here are these points here, and you might say this looks kind of like a parabola, but I only use the integers. But taking a look at this, okay? Now, one easy way to tell that this is a function is to simply take all of these points and necessarily label them. So we had negative 2, 2, we had negative 1, negative 1. 0, negative 2, we had 1, negative 1, and 2, 2, 2. And you'll notice that every x value, each individual x value goes to one and only one output. But the unique thing about looking at a graphical situation is this. We can use what we refer to lovingly, I hope, as the vertical line test, okay? So think about this. A vertical line, if I drew a vertical line, each vertical line that I draw has to pass through an x value. Say it has an associated x value. And of course, if we're interested in a function, which basically states that every x value is allowed to go to one and only one output value, so each of these x's I'm drawing to their respective y's, this one actually is a function because every x value mapped onto one and only one output value. But let's just say for the sake of argument here, this is a function, okay, by the way. Let's say for the sake of argument, I had an x value that would have mapped onto, say, 2 output values. So, to really get this in there, maybe we go with blue here. What if I had this point right here, this x value over here, the x value 2, not only did it go to a height of 2, but it also went up here to a height of 4. And then let's also say that I passed a vertical line through this, which, by the way, that vertical line has to go through that one x value. If this vertical line were to strike more than one point, okay, so that's the important thing here. If I could draw a vertical line through a relation, a graphical relation, and it would strike that relation 2 or more times, it would be fair to say then we had an x value that proceeded to go to more than one y value. In other words, an input that proceeded to map onto more than one output, which, according to this definition of function right here, okay, violates the rules for being a function. So, the vertical line test, okay, vertical line test simply states that if we have a graphical representation of a relation, if anywhere I can draw a vertical line, it were to strike the relation in more than one spot, then it is not a function. And likewise, if I can draw a vertical line anywhere, and the only rule is this, and it could never hit the relation more than one time, okay? It might not even hit it at all, but so long as it doesn't hit it more than one time, we would consider it a function. So considering the original red points, there would have been nowhere, even this yellow line right there, even though it didn't hit it, at least it didn't hit it 2 or more times, we would consider it a function. Okay. And then the final representation we're going to be talking about today, this representation is an equation representation of a function, okay? So this is how we tend to go with functions, but we represent them with an equation. So I want to start by looking at this one right here. We say y equals x squared. And I can tell you right now, we'll start with the answer. That's fun to do sometimes. This is a function, but we say, in this instance, y is a function of x, okay? So there are a couple of different ways we could tell this, but starting with this one, check this out. We already notice here that y is isolated on the left. And if you want to look ahead here, you'll notice that y is not isolated in these next two examples, but y is isolated on the left, but we have all the x's on the right. And so once we've isolated y, the question happens to be this. If I could choose any x value to plug in right here, let's say I chose an x value of 3, and we plug this in and we say, okay, so y would be equal to, in this instance, y would be equal to 3 squared. Well, 3 squared is 9, In other words, when we have an x value of 3, we would have a y value of 9. There is no possible way that we could select an x value for which, when we plug it in, we get more than one output value or more than one y value. So we say, looking at this, y is a function of x. But a simple way to tell us is when y is isolated, over here we have a series of x's. We don't have anything that might say like plus or minus. Okay, so let's take a look at this here.